Hello, Professor. So for the second problem, I chose question number 7 for homework 2B. And it says, suppose that the resistance between the walls of a biological cell is 4.4 times 10 to the 9 ohms. So first of all, what is the current when the potential difference between the walls is 75 millivolts? So I'm given ohms, or so this drawing that I did represents like a cell, and then between the cell walls, there's this ohm, which is R, and that is the resistance of the conductor. And this is measured in ohms, which is here. And then we're also given, or it asks what the current is. And the current would be I, and the rate, which is the rate at which charge passes a given cross section. And the SI units for this would be amps. And so I'm also given millivolts, the potential difference. So V is the potential difference, and it is voltage between ends of a conductor. And the SI units for this is volts, which would be V. So I know that I'm giving these three things, and so I know I'm going to be using Ohm's law, which is V equals IR, current, and then resistance. But I have to manipulate this formula to be able to get I equals V over R. So to get I by itself, I just divide by R over here, so that gives me I equals V over R. So then, first of all, I have to convert my millivolts to volts because our SI units is in volts, not millivolts. So I divide by the 75, I divide 75 millivolts by 1,000 millivolts to be able to get 0.075 volts. And then I divide it by my ohms, which I'm given here, and then I'm able to get my amps, which is 1.7 times 10 to the negative 11 amps. So that is my current that is there. And then B, what is the current, or if the current is composed of Na plus ions, how many such ions flow in 0.56 seconds? Okay, so for this, I have to be able to find my Q, which is the value of point charge, and I do this by using my I and my T. So I use this formula because I have my current that I just solved for, and then I'm also given time. So I know that I'm going to be using this formula because I need my my value of the point charge in coulombs. So I multiply these two, I manipulate this formula to get Q by itself, so it ends up being, I multiply it by T to get T over here, so then Q equals I over T, and so then I multiply my amps that I have times my seconds to be able to get a Q of a value of point charge, 9.52 times 10 to the negative 12 coulombs. So in this problem, I know my value of point charge because I was able to solve for it, but now I want to be able to solve for how many of these ions are actually there. So not the coulomb amount, but how many is within this coulomb. So I know this because I know for one electron it is 1.6 times 10 to the negative 19 coulombs. So I cancel these out. So I divide my whole coulombs by my 1 electron coulombs to be able to cancel out these units, to be able to say that I have 5,950,000 ions. And this is composed of no units, which you see up here, because these two cancel out. And then in my previous problem that I just did, we did the same thing using this number, the 1.6, because that is our ion charge that we are given by searching. So yes, thank you.